Page 12 of differentiation rules. Consider the function f of x equals 2x cubed minus x. Complete the following table by indicating whether f of x, f dash of x, and f double dash of x are positive, negative, or 0 at the given value of x. Okay, so I'm just going to find the first derivative of this, and it's 6x squared minus 1. And then I'm going to find the second derivative, and it's going to be 12x, right? Then I'm going to plug in negative 1, 0, and 1 into this expression to see when it is negative, positive, or 0. So if I put negative 1 in there, it'll be 6 times negative 1 squared, so 6 times 1, minus 1, right? So it'll basically be 5. So that would be positive, right? And if I put 0 in there, it would be 6 times 0, which is 0, minus 1, which would be negative. And if I put 1 in there, it would be 6 times 1 squared, which is 6, minus 1, which is positive 5. So it's positive, right? Oh, and what about the original expression? If I put 0 in there, it's 0. If I put 1 in there, it's 2 times 1 cubed minus 1, so it's 2 minus 1 is positive. Okay, and then finally f double dash. So f double dash, if I put negative 1 in there, it'll be negative 12, so it's negative. If I put 0 in there, it's 0. And if I put 1 in there, it's going to be 12 times 1, which is positive. Okay, so basically I filled in this table just by putting the values negative 1, 0, and 1 into the first and the second derivative. We don't know exactly what that means yet, but in the next unit we will be talking a lot about the physical meaning of positive, 0, and negative first derivatives and second derivatives. That's like the whole point of the next unit. Number 7. Given that f of x equals 2/3 sine 3 of x, show that the third derivative with x equals 2 pi over 9 plugged into it is equal to 9. So first thing I'm going to do is I'm going to take the first derivative, and I'm going to get 2/3, and the derivative of sine is cosine something, right? And then I need to do the chain rule, so I multiply this times the inside function's derivative, so 3. And that gives me, and if I simplify it, I need to simplify it because I'm going to take another derivative after that. I get 2 cosine 3x. Okay? And then I'm going to take the second derivative. The second derivative would be, the derivative of cosine is negative sine. So I'm going to put 2 times negative sine of something times the chain rule. So the answer is negative 6 sine of 3x. Now I'm going to take the third derivative. So that would be negative 6, and the derivative of sine is cosine, remember, so I'm going to put cosine 3x, cosine of something, and then I'm going to multiply it times the chain rule, which is 3. So that would be negative 18 cosine of 3x. And then I'm going to plug in x equals 2 pi over 9. X equals 2 pi over 9. And when I do that, I get negative 18 cosine of 3 times 2 pi over 9. And 3 times 2 pi over 9 is equal to 2/3 pi, right? 2/3 pi is 120 degrees. Cosine of 120 degrees is negative 1/2. So that is equal to negative 18 times negative 1/2. And so that is equal to 9. Number 8. Suppose that f of x equals 2 sine cubed minus 3 sine x. Show that the first derivative is equal to this. Okay, so derivative of 2 sine cubed x, we're going to have to do the chain rule. We do 2 times 3. We take the exponent of sine cubed x, and then we reduce the power to squared. Okay, and then we take the derivative of what's inside, so it would be derivative of sine x is cosine x. This may be a little bit confusing. I'm going to rewrite this so that it is has the notation that maybe you can recognize more that it would be chain rule. So I'm going to put sine x, and then I'm going to put cubed on the outside. Okay? Let's do it like that, and then maybe it's easier to remember that you need to do chain rule on the inside. Okay, so I'm going to put 2 times 3 times sine x squared. Do you see how I reduce the exponent? Now I take the derivative of the inside, cosine x. Then the derivative of negative 3 sine x would be negative 3 cosine x. Then I simplify this. It's going to be 6 sine squared x cosine x minus 3 cosine x. Then I am going to factor out a 3 cosine x. So I'm going to have 3 cosine x. Maybe I'll factor out a negative too because they have a negative here. So I'll do negative 3 cosine x. I'm going to factor that out. So I end up with negative 2 sine squared x minus or plus 1, right? Now, does that look familiar? 1 minus 2 sine squared x. 1 minus 2 sine squared x is another way of writing cosine 2x. So this is actually equal to, and if you don't remember that, look on your formula sheet. Cosine 2x is equal to 1 minus 2 sine squared x. That's one of the identities for cosine 2x. Now let's find the second derivative of this expression. Okay, so we're going to have the second derivative of that is going to be, we're going to have to use product rule, right? So we'll have negative 3 on the outside, and on the inside we're going to have cosine x, and then we'll multiply times the derivative of cosine 2x. The derivative of cosine 2x would be negative sine of something, multiplied times the derivative of the inside, which would be 2. And then we're going to do product rule. So then we're going to take the derivative of cosine x, which is negative sine x, and then multiply it times the original function cosine 2x. Okay? And then we can simplify this a little bit. We can distribute the negative 3 to both. And let's see, we'll have negative 6, or positive 6, sine 2x, and then we're going to have cosine x, minus, or plus, 3 sine x times cosine 2x. So number 9, we're going to find the second derivative of x natural log of x. So the first derivative would be product rule. So I'm going to take x times the derivative of natural log of x plus derivative of x times natural log of x. That gives me x times 1 over x is 1 plus natural log of x. That's the first derivative. Second derivative would be derivative of 1 is 0, derivative of natural log of x is 1 over x, so it's just 1 over x. Okay. C. The first derivative is going to be chain rule because we have natural log of x in the inside and we have squared on the outside, so we put 2, and then we put the inside function to the first power. We reduce the power 2 to 1, and then we do chain rule on the inside. Derivative of natural log of x is 1 over x, so we have 2 over x times natural log of x as the first derivative. The second derivative, we would do maybe, let's do product rule, so we 2x to the negative 1 times natural log of x. So first we're going to write 2x to the negative 1, and then we're going to multiply times the derivative of natural log of x, and then we're going to take the derivative of the 2x to the negative 1, which would be negative 2x to the negative 2, and then we just multiply that times natural log of x. So that gives us 2x to the negative 2. minus 2x to the negative 2 natural log of x. We could factor out 2x to the negative 1, or negative 2, and that would be 1 minus natural log of x on the inside. Number 11. If y equals this function, show that the second derivative of the function minus 7 times the first derivative of the function plus 12 times the function itself equals 0. This is kind of like getting you guys ready for differential equations, because in differential equations, if you take that in your future, they're going to give you this equation, and then what you do is you try to figure out that the solution to the equation was this. Okay, but we're doing the opposite. We're just going to substitute it in. So the first derivative of this is going to be 2 times 3 times e to the 3x. And 5 times 4 times e to the 4x. So it's, if we simplify it, it's 6e to the 3x plus 20 e to the 4x. And the second derivative of that is going to be, and as you can see, it's important to simplify this to make it easier to take the derivative. It's going to be 18e to the 3x plus 80e to the 4x. Do you see I already multiplied it times the coefficients? Now I'm going to do the test. So I'm going to try to put the second derivative here. So it'll be 18e to the 3x plus 80e to the 4x minus 7 times the first derivative, which is 6e to the 3x plus 20e to the 4x plus 12 times the original function, which is 2e to the 3x plus 5e to the 4x. Oops. Okay. So we're going to rewrite this again. Plus 80e to the 4x minus 42e to the 3x. Plus, minus 140e to the 4x plus 24e to the 3x plus 60e to the 4x. Okay, now let's see. What are the coefficients for all the 3x terms? Okay, so it would be 18 minus 42 plus 24. So 18 plus 24 is 42. So 42 minus 42. So indeed, the e to the 3x terms all cancel out. Let's look at the e to the 4x terms. 80e to the 4x minus 140 plus 60. Yeah, 60 plus 80 is 140. 140 minus 140 is 0. So the e to the 4x terms also all cancel out. So it really does equal 0. Okay? All right, last one. If y equals sine x, show that the fourth derivative of sine x is equal to itself. Okay, so the first derivative of sine x is cosine x. Second derivative of the second derivative, which is the derivative of cosine x, is negative sine x. Third derivative is equal to negative cosine x. And the fourth derivative is equal to negative times the negative of sine x is equal to sine x. So the fourth derivative of sine x, you get back to sine x again. And that was the last problem.